In this video, we're going to talk about how to find compositions of functions. So let's go ahead and get started. Here we have f of x and here is g of x. So part A is asking us to find f of g of x. So that's the way you read this little o. It looks like fog, but what it's saying is that little o is an of. So f of g of x. Okay, so we could rewrite that as f of g of x. Okay, so these two are the same thing. All right. So basically, what it's asking us to do is, when we're looking at f of x, go ahead and plug in g of x everywhere you see x. Okay, so I'm gonna plug in g of x. So I see f of x is x plus 3. So g of x plus 3. Right? X plus 3. So g of x plus 3. Right? I'm plugging in g of x everywhere I see x. Alright, so what is g of x? G of x is the square root of 2x minus 1. So I'm going to go ahead and plug that in. 2x minus 1 plus 3. Okay, so I plugged in this g of x, right? These two are the same, plus 3. So there we go. That's f of g of x. So I can circle that. Now, to find its domain, really we need to be concerned that 2x minus 1 needs to be positive, right? So 2x minus 1 must be greater than or equal to 0. So let's go ahead and add 1 to both sides. 2x must be greater than or equal to 1. X must be greater than or equal to 1/2. So the domain then would be 1/2 to infinity. And this is the domain. Okay? Alright, so let's go ahead and move on to the second example. So this one says f of g of 1. So what it's asking, this is the same thing as f of g of 1. Same thing. So let's go ahead and we'll do the exact same process. So I'm going to plug in g of 1 in for x in f of x. Okay, so that's going to be the first step. Plug in what you see here into f, right? And then, so now, let's go ahead and plug in 1 into g of x. So that's going to be the square root of 2 times 1 minus 1 plus 3. So that's the square root of 2 minus 1 plus 3, which is the square root of 1 plus 3, which is square root of 1 is 1, so that's 4. Alright, since you had already, so that's your answer. So since you had already found f of g of x over here for part A, you could have also just plugged in your answer to this equation, to this function over here that you'd already found, right? So had you done that, so you knew f of g of x, you knew already that this equals the square root of 2x minus 1 plus 3. So when you're then trying to find f of g of 1, you could have just plugged in 1 for x. So 2 times 1 minus 1 plus 3. 2 times 1 is 2, minus 1 is 1, square root of 1 is 1, plus 3, which equals 4. Okay, so you'll get the same answer. Alright, so now, say we were to find g of f of x. So this one says g of f of x. So now first thing I'm going to do is I'm going to look over to my g function and I'm going to plug in f of x everywhere I see x. Okay, so I'm looking at this and wherever I see x, I'm going to plug in f of x. So this is going to be the square root of 2 times f of x minus 1. Okay, now, so let's see. This is going to be the square root. So let's go ahead and plug in what we see over here for f. So that'll be 2 times x plus 3 minus 1. So that'll be square root of 2x plus 6. I distributed the I distributed the 2 into x plus 3. So 2x plus 6 minus 1. Okay, so that's the same thing as 2x plus 5. Okay, and there you go. That's my answer. Now, to find the domain, I need for 2x plus 5 to be greater than or equal to 0. Okay, so if you were to subtract 5 from both sides, the same thing as 2x needs to be greater than or equal to negative 5, or x needs to be greater than or equal to 5, negative 5 halves. Right? So my domain for this one, I'm going to go ahead and erase this here so I can write it here. So negative 5 halves all the way to infinity. And that would be my domain. Alright, last one. Let's do f of x. So that is, it's asking us to find f of x. Alright, so I'm going to do the same process. I go over here to f, and then every time I see an x, I'm going to put in f of x. So I'm going to put in f of x plus 3. Right, so this f of x here is replacing this x. Now, let's plug in f of x for this. So this will be x plus 3 plus 3, x plus 6. And that's your answer. Now, what's the domain of this? Well, domain will be all real numbers. Negative infinity to infinity.